Welcome to a lesson with Dr. Powell. As promised in this video, we'll work through the details for finding the derivative of g of x is equal to x times natural log x. Following this video, we'll give a visual demonstration of what we talked about in the last video. Okay, so this was our box A, that was our box B, and what we'd like to do is take the derivative of kind of the scenario where b is held constant. I'll write it like that with respect to x, plus the derivative of the function where a is held constant and b is like the variable. Now, taking the sum of those, so a is a variable, b is held constant, b is the variable, a is held constant, and that's going to be the derivative that we're after. But let's look at this a little bit here. This is kind of like the situation where we have, this is kind of like taking the derivative with respect to a. This is like saying dg dA, where b itself is like a variable. So we can even think of g as being equal to a times b, where b is a constant. And then in this situation, we're going to be looking at taking the derivative of g with respect to a. Then, to get the derivative with respect to x, we can multiply by the derivative of a with respect to x. So, in this case, that's exactly what we're going to do. This derivative is actually pretty simple to take. G is equal to a times b. Let's think about that, where b is a constant. Well, that's like saying, let's pretend b is like 5. And I replaced it. So instead of a times 5, I wrote 5 times a. What's the derivative with respect to a of this, where a is the variable? Well, it looks like 5, right? Or in other words, b. So if we rewrote this, we could think that this part is simply b, or natural log x. What's dA dx? Well, the derivative of x with respect to x is just 1. Okay. Now, so we're done with this part. It's just natural log x. What about this piece right here? Well, similarly, let's think g is equal to a times b, and think the derivative with respect to b, where a is now a constant. Well, a is the constant, b is the variable. The derivative should be pretty clear. It's just a. So we get, which is just x. So we're thinking about this, dg dB. This part right here will simply be x. Now what's dB dx? Let's see. Well, what's the derivative of this with respect to x? It's just 1 over x. So we end up getting natural log x plus, this is just 1. And that right there is the derivative of g of x. We just computed it. It's natural log of x plus 1. And this same basic technique can work with any two expressions put together, and even 3 expressions, 4 expressions, and so forth. We basically focus on one box at a time being a variable, and the rest being constants. Of course, our picture would have to take on new dimensions and new directions to really make it work from the last time. But the same principle holds, and we get a nice description of what the actual derivative is, what the actual slope is. And it all comes from tangent line relationships and how things look like up close. Thanks for watching.